did yesterday. Again, discard from the rational zero theorem. Today, we put it all into motion as far as finding the zeros. Yes?
So, the world says with this, we're putting all 3 days together to solve one problem.
Correct. What did we do? Correct. It's like on Thursday, gentlemen. It's like Thursday. Tomorrow, we're actually going to be looking at incorporating the complex numbers of conjugates. So, correct. Yeah, it's all comes down to this: finding the zeros.
So, like, we'll just be given a deal, and then we'll have to go through everything we write down, everything we do today, and then tomorrow to get the answer.
Yes. Well, I mean, these are the steps right here.
Okay.
However, tomorrow we're giving you some extra stuff as far as talking about complex numbers more so. So first things first, we're going to decide the number and the type of the roots. How did we do that yesterday? Like the number of positive, the number of negative real zeros. Yeah, absolutely. So using discards little signs. As Chris said, just counting up this variations of signs, the sign changes, right? So after discards. That's what we did yesterday. So after that, then we can list all possible rational zeros, right, by using the rational zero theorem, which we just went over there for the homework. Hopefully it's not that big, right, the selection. So once we have all that, again, this is all stuff that we did previous day, yesterday. Once we have all that information, then we can go ahead I hear a little moaning, but using synthetic division, and factoring. So using our synthetic division and factoring, we can go ahead and break that polynomial down into a degree less, all the way until we get to the next square term, right? Then it just becomes a simple matter of solving a quadratic, whether you use the crisscross method, box method, or even the quadratic formula, right? So the only thing we're adding today is doing the synthetic division and then factoring. So starting off, we're going to find all the zeros of f of x equals x cubed minus 5x squared minus 22x plus 56. Is there a GCF to factor out? Can I factor by grouping? No. So, first things first. How many roots, how many zeros does this polynomial have?
3.
Why 3?
Because that's how it is.
It is a third degree polynomial, so absolutely. We're going to have 3 zeros. 3 zeros in the complex number system, right? So whether they're all real zeros, real and imaginary, whatever have you, but I have 3 of them. So now, using Descartes' rule of signs, 2 or 0, absolutely, because we go from positive to negative, negative to positive, only 2 sign changes, or an even number less. As Chris is trying to figure out f of negative x, how many we got there for our negative?
1.
Just 1? Pretty sure? How did you guys do that? Sean said, we'll find our f of negative x. What is my f of negative x?
Negative x cubed minus 5x squared.
Don't try doing it in your head. Write it down. It only takes a few seconds, right? So here we can see, as you guys already told me, there's only 1 sign change. So for my negative real zeros, I'm only going to have 1. It tells me for a definitive answer, I know I have 1. It's not this or that. I know there's 1 negative. Everything else has to be positive or complex. So now for all of our rational roots, well, it's going to be factors of what over what?
P over Q.
P over Q. In this case, P is 56, my constant term, and Q. So we don't even have to worry about that Q, right? So, factors of 56, folks. I'll start off with a tough one. Plus or minus 2. Is that it? Well, you got a 7 and a 2, right? Sorry, Edwin? So we have a few choices to choose from here, right?
Yes.
But I know that if I do have a rational 0, it has to come from here. How do we decide which one? Division. But not long division, synthetic, right? Synthetic is quick and easy. So, where do we start with? Well, where do we start? Okay. Or if you like 56, you like the big numbers, start from there. The more and more you do this, so homework, right? The more and more you do this, the more patterns you actually see, and you say, well, I don't want to do this number. I can pretty much see it's probably going to be one of these two numbers. That is the way that you do become proficient at this. So homework is not just busy work, folks. It's not just for a grade. It helps reinforce those patterns. So,
You overestimated my powers.
so he said starting off, so if you start off with, say, the 1, and then we put down our exponents, not our exponents, but our coefficients. 1, -5, -22, and 56. So, drop down to 1. 1 times 1, and -4. -4. Did that work for us? No. What am I looking for? I'm looking for a remainder of 0. Remainder of 0 tells me that it's a factor. 1 did not work. What should we try?
4.
Okay. I was going to say -1, but if you guys want 4, fine. So 4. I will let you know ahead of time 56 does not work. I don't want to do 56 yet. So, so 1.
Nope, it's not. Sorry.
So 4 did not work. What should we try now? -1?
Yes, -2.
2.
Saying -1 for a reason.
Well, Reed says 2, so we'll try 2. Folks, unfortunately, this is the way it is. With these type of problems, there is no start off here and this will be your answer. If you have 16 possible answers, maybe that only one of them works. It could also be what? None of them work. And you go through every single one.
Are you serious?
You go through every single one, and what? It's going to be a complex number, imaginary, or perhaps it's irrational. But, you think I'll give you something like that?
I hope. Yeah, no.
Only for reading.
Yeah.
So here, let's try 2, folks.
2. There's this. Ooh.
So here we used the 0x equals 2.
So that's 1 in our problem. That's 1.
Well, what did we get What are these? What is 1, -3, and -28? These are my coefficients for my factored polynomial, my reduced polynomial, right? This is what? X squared. So I took my f of x, right? My x equals 2 was my 0, which means x minus 2 is my factor. So the third degree polynomial we started off with has now been reduced to x squared minus 3x minus 28 times x minus 2. So now there is no reason to use synthetic division anymore. We have a quadratic which we can simply factor to what? You could definitely use synthetic division if you want to, but again, you don't know where to start with. Plus minus?
X minus 7. 24.
So here we have completely factored a polynomial. First thing we did is we started off with, we had to choose a 0 to start off with because there's no way to factor that third degree polynomial, right? But now we reduced it to one of the factors as being quadratic, right? And then we just solve how we normally solve a quadratic, crisscross method, quadratic formula, however. And so what are my zeros then?
7, -4.
-4.
So I have what? 1 negative, 1 negative, and 2 positive. So now it could have been 0 positives. Just because we had the 1 negative, it does not mean that there were 2 positives. It still could be 0 positives, and the other 2 could have been complex or irrational. Remember, this is, excuse me, these are, right, or it could have been, yeah, correct, it could have been irrational, so it would not come from this list of possible rational numbers. So, let's try this one. Find all zeros of f of x equals x cubed minus 3x squared plus 2x minus 6. So, Dominic, how many zeros do I have here? 3. Absolutely. Since I have that third degree polynomial, I have 3 zeros. And Gil, how many positive real zeros can I have?
Wait, what was the question?
Positive real zeros. So using Descartes' rule of signs.
2. Oh, 3.
3 or?
0. 1.
3 or 1. Absolutely. Or, again, actually there are 3 sign changes or an even number left. So 3 minus 2, 3 or 1. And for our negative, what do we have? 0. 0. So if we go ahead and do our f of x or f of negative x, we see that we have nothing but negatives. There are no sign changes. As Chris said, we have 0 negative real zeros. So now when we come up with our possible rational zeros, again, we're doing what over what? P over Q, where P is my, or P are my factors of my constant term, and Q factors of my leading coefficient. My leading coefficient is 1, so I'm just looking at the factors of 6, which are what? However, Kyle said, we already know from here there are no negative real numbers, no negative real zeros, so I can eliminate half of the possible zeros. And now we just have 4 zeros to look at, which definitely is a lot better than the last example where we had a little bit more than 4. Right? So now we have 1, 2, 3, or 6 to choose from. Sean, what should we start with?
3.
Okay. Why 3? Is everybody saying 3?
Yeah.
So, whether you decide 1, 2, 3, or 6, choose something, right? So 3. So 1. What do we get here?
1, 3, 0, 0.
Absolutely. So here we can see 3 did work. X equals 3. And this gave us that 102 for my coefficients of our quadratic, which are what? So we've taken this third degree polynomial, my f of x, using the 0. Don't forget, right, that 0 of x equals 3 is the same thing as saying the factor of x minus 3. So we have now reduced it to a quadratic. I know the 0 here, x equals 3. To find the 0 for my x squared plus 2, what do we do? To find the 0, we just set it equal to 0. Sorry? Subtract 2. Square root. I think I hear the answer. What is it? So here we come up with x equals plus or minus square root of 2i. Again, the I comes out with that negative square root of 1. So my zeros what else? 3. If I want to write, these are all my zeros. If I want to write my f of x in factored form, what does that look like? These are negative what? Reals. I is not a real number. So here it says I'm either going to have what? 3 or 1 positive real numbers, right? And sure enough, we have 1 real, which was the case here, and we don't have any negative real zeros at all, right? So here we come up with our zeros of plus or minus root 2 times I, and 3, or in the factored form, x minus root 2i, x plus root 2i. X over. Well, if they ask you factor out the polynomial, or what is the factored form, that would be this one. If it said, as this problem did, it said I can find the zeros, find all the zeros. We're not looking for this, we're actually looking for this answer right here. Put them all on, express all. Not too bad, right?
Yeah.
Here we're going to find all the zeros, and this is different than in your handouts, folks. Find all the zeros of f of x equals x to the 4th minus 4x cubed plus 8x squared minus 16x plus 6. That's what I just said. I said this is not the same as what's in your handout. So, the other one that you have, you can do for fun. It wasn't really fun for me. So, if it wasn't fun for me, I don't think it would be too fun for you guys. So, in this particular one, Antoine, how many zeros? positive zeros. Absolutely. Since there is 1, 2, 3, 4 sign changes, as you said, 4, 2, 0. Right? Keep on remembering, it's that number of sign changes or you need a number less. So 4 minus 2 is 2, 2 minus 2 is 0. So one of those 3 possibilities. For my negative, say, first we need to find out what f of negative x is.
Yeah.
Absolutely. As we wind up with our x to the 4th, all positives, no sign changes, so we know right off the bat, again, there are no negative real zeros. And then finding those rational zeros, the possible rational zeros, p over q, my factors of what over what?
16 over 1.
Help us out there, Dominic, then. Just positive one or any negative? Can I have negatives in there?
No negatives.
Absolutely. So 1,
That's good. 4, 8.
only a few choices to choose from here, right? So, 100. What should we start with? Do we have any idea? We do know that possibly one of these 5. Hopefully one of these 5. Again, it could be, and I do not plan on giving you anything on the test, folks, or quiz where none of these will be your answer. I do not want you spinning your wheels and finding out what did I do wrong, right? So you start somewhere. 2? All right. And we have what? 1, negative 4, 8, negative 16, and positive 16. So Alex, what do we get here?
1 and 2, negative 2, negative 4, 4, 8, negative 8, negative 16.
So some of you guys are choosing the right numbers here. And again, hopefully it's, I don't know if it's trial and error, but sometimes you can just look at these problems and say, I can see one will never work. Let's go to the next one, right? Or you say, I think one won't work, so let's go to the next one, and hopefully it wasn't one. So in this case, x equals 2 works. So we wind up with
So it's 2x squared plus 4.
we're still not down to a quadratic, so what can we do? So we do synthetic division again, right? So what factors work for this? The exact same, right? I still have my same ones, 1, 2, 4, 8, 16 to choose from. If it factored my 4th degree polynomial, it's going to factor that 3rd degree polynomial. Can I eliminate one of them now, though? So can I eliminate 2? Why not? If Phil says no, we shouldn't, for whatever reason. Everybody else says yes.
No,
What
because,
if you got it again? You can't have.
because you could get it again.
What's that
But
called?
if you get it again, you just have multiplicity.
Bingo.
Absolutely. Don't forget, we covered zeros of multiplicity, right? So it doesn't mean that since I used to, I should eliminate 2.
So,
Because I may have x minus factored form, I may have x minus 2 times x minus 2 times x minus 2, right? I may have multiple x equal 2s. So, sure enough, if we take a look at this, so here we can see we have another x equals 2. So my factored form, we had our two of them already, right? And then this one, x squared plus 4. So I need that. Again, I'm looking for my zeros. So I need, what do I need to do with that x squared plus 4?
or choose.
You don't like 2, Sean?
No, not anymore.
So, what were my zeros? There's -4, so when I do the square root right here, folks, listen up. So when I have the x squared equals -4, right, we take that square root of both sides, and that's where we get that, the I from that negative in the square root.
I just left the negative on.
Okay, yes.
Do we need to write the multiplicity if there is one?
Yes, definitely write down that multiplicity so it doesn't look like, oh, I just saw this one and I'm good to go. So definitely write down the multiplicity if it has it. And so these are my zeros, what the problem asks, but factored form of my equation is what? What's that? So x minus 2i. Whether you write x minus 2 or twice or x minus 2 squared. There's a question asked, though, or not even asked, but did I need to do this at all? Why not, kid?
You could have used factor by grouping.
Absolutely. If you take a look at this, Kate was the only one who saw that. I can quickly cycle him. And that's something, again, just like when we did the law of cosines. You guys remember from way back whenever we did the law of cosines? When we did the law of cosines, you didn't have to do law of cosines for every single side, right? Or every single angle. Once you found that one angle, then you said, oh, I'm going to use my law of cosines. Same thing here. Just because we have a very large polynomial, we reduce it. We don't have to keep reducing it to quadratic. I mean, that's definitely one way of doing it. If I don't see anything at when I have a third degree polynomial here, definitely do synthetic division again until we get down to quadratic, which we know how to solve. If you do have a polynomial such as this one, x cubed minus 2x squared plus 4x minus 8, and say, hey, this is just factor by grouping, factor it out. Right? It was just a simple, as Kaden said, using our factor by grouping, you wind up with that exact same answer. Yes? No? Questions on that, folks? So tomorrow we'll go ahead and look at factor by